Hello, Trailblazers. So I'm back. I made it to Washington, D.C. now, and I have one more flight to catch, and then I'm at my brother's wedding. So we are now going to, on page 6, you're going to look at the top 3 examples here. I'm going to go through these 3 examples with you guys, and then you guys will get a chance to practice a little bit on your own. Okay, starting here. We have the nuclear decay equation for alpha decay of uranium-238. So the first thing you're going to do is you're going to take uranium-238 and you're going to write the complete symbol. Remember, the number after uranium is the mass number. So you have uranium, that's a U for the symbol, and you're going to put 238 on the top because that's the mass number, and then you would put 92 on the bottom because that is the atomic number. Okay. It's going to decay, and what that means is it's going to break apart into 2 pieces. We don't know what both of those pieces look like, but we know one of those pieces is going to be an alpha decay. So we're going to go ahead and write that piece of the alpha. And again, the alpha looks like 4 over 2 with a helium symbol, or you can draw the alpha symbol. Either way it works. Plus, now we have to figure out what that other piece might be. Remember, so 238 needs to be is the top number on the left. And then 4 plus something is going to give you 238 on the other side. So 4 plus what gives you 238? It would be 234. So 234 is obviously our mass number here. Now we're going to take the atomic number of 92 on the left, and we have to figure out 2 plus something else is going to equal 92. So obviously that would be 90. So now you would look at your periodic table, and you would find the element with atomic number 90, and you would say that's thorium, so you would put that. At this point, this is your entire answer. A lot of students would like box this area. You don't have to box like the missing piece. If you're going to box something, box the entire thing, right? This is a nuclear decay equation. Okay, next one. Now we're going from iodine 131, and it's undergoing beta decay, so again we're going to use iodine. We're going to go ahead and write the complete symbol. So we have iodine is the I, capital I for iodine. 131 is the mass number, and if you look up iodine on the periodic table, the atomic number is 53. Again, we don't know what both pieces are going to look like, but we do know one of the pieces has to be a beta particle because that is the piece that is missing. So we draw the beta particle, which is 0 as the mass number, and then -1 as the atomic number. So now we have to figure out what our missing mass number would be. Obviously, if it's 131 on this side and then 0 on this side, the other mass number must be 131. And here we have to figure out for the atomic number, if both sides are equal to 53, what minus 1 gives you 53? So obviously that would be 54. So 54 would be our missing atomic number. So now we go to the periodic table and we're looking for the atomic number 54, and that would be xenon, the noble gas there. So again, this would be your entire answer. This is what iodine 131 looks like if it's undergoing beta decay. Alright, let's go on to our final example, which is gamma decay. Gamma decay is actually the easiest one, so we need to write the nuclear decay equation for a gamma ray. So we're first going to start with carbon 14. So carbon is the symbol C, obviously. The mass number is 14, and the atomic number for carbon is 6. For gamma rays, the mass number is 0, and the atomic number is also 0. So really everything here should be unchanged except for the symbol. So obviously if we're looking for the mass number, if it's 14 on both sides, 0 plus 14 is 14. And then on this side, if we're looking for the atomic number, if both sides equal 6, we need to figure out what the atomic number would be, is 6. So again, you have a carbon here. You're probably wondering, like, what's the point of all this? Gamma decay just basically says that a lot of energy is being released, so when they say gamma, you should think of like energy being released. Okay, on page 6, you guys have a bunch of other practice problems. They're at the bottom. Let me just drag this in here. Oops. Yeah. Okay, let me zoom in. Alright, I want you guys to complete where it says homework for nuclear chemistry. I want you to do questions 1, 2, 3, 4, 5, and 6. So yeah, those 6 questions. When you finish those, because they shouldn't take you very long, you can check your answers with the keys at the table, and then you can complete your homework, which is on page 7. If you have any questions about the diagram, I'm going to have a key in there tomorrow for you guys so that you can answer questions about it. All right. Then once again, I thank you guys for your attention, and I know you're going to be very respectful to who's ever in the room right now. So go ahead and take the rest of the class and finish those 2 assignments. If you finish early, you can work on some physical chemical changes questions earlier in the packet, or you can work on an assignment for another class. All right. Thank you very much. Have a good day.